All right, guys, we're starting 10-1 today. We're going to add and subtract polynomials. The first thing we need to know is what a monomial is. A monomial has one term, like maybe 3, x, oops, I don't know where I wrote 8, x squared, 4x squared. All of those have one term. That is a monomial. Now, we're going to be adding and subtracting polynomials. Polynomials are just the sum or difference of monomials. The first one we have is a binomial. That's going to be 2 terms. Maybe something like x plus 4. Maybe 2x squared minus 3. Maybe x to the third minus x squared. But all of them have 2 terms. It's a binomial. A trinomial has 3 terms. So maybe something like x squared minus x plus 3. 3 terms. Maybe 4x to the third minus 2x squared minus x. 3 terms. So binomials and trinomials. We're going to be adding and subtracting them today. So basically it's a matching game, okay? Now before we do this, I want to just make a point or two. Before we had like 2x plus 1. We could not combine those terms because one had an x and one had a 1. Well, the same thing kind of goes with what the next part says. If I had x to the third plus x squared plus x, those cannot be combined. Those are the things you're needing to match. You can add x to the third to any other thing that has x to the third, but nothing that has like x squared or x. Same thing with x squared. You'll have to look for only the terms with x squared. So let's look at number 1 and see how it works. Number 1 says combine all like terms and write the resulting polynomial. Now, if you don't remember, there's actually a 1 right there in between the plus and the parenthesis that we would normally have to distribute, but since it's positive, it's just going to stay the same. So I have 2x squared plus 3x plus 2 plus x squared minus 5x minus 5. Now, this is where we start matching. We combine our like terms. So we're going to start with the leftmost term, and I'm going to underline 2x squared, and I'm going to go look and underline anything else that has x squared. I'm going to match them up. Well, the only 2 I have are 2x squared and x squared. Well, that's just basically take their coefficients. What's 2 plus 1? Well, that's 3 x squareds. I'm going to go ahead and put a line through those so I don't accidentally use it again. I'm going to go to the next one. I'm going to box it in. This one has an x. I'm going to look at all the terms left. I'm going to box any of them that have just x. Now I have 3x minus 5x. 3 minus 5 is negative 2x. Get rid of those. Then I have 2, so something with no x's. Well, I have negative 5. 2 minus 5 is negative 3. I have something with x squared, something with x, something with no x's, so nothing else can be combined. There's our answer. So it's just a matching game. Match up your x's, x squareds, x cubes, anything like that, with other ones with the same symbol, and then combine them together with addition or subtraction. All right, let's look at number 2. It's a little bit different. It says take the opposite of all the terms in the second polynomial, then combine all like terms. Well, the reason they're saying switch, take the opposite of each term, is because now we don't have plus 1, we have minus 1. So we have to distribute that negative 1 across my parentheses. So I have 2x squared plus x minus 4. Negative 1 times x squared is negative x squared. Negative 1 times negative 4x is positive 4x, and negative 1 times 1 is negative 1. Now we're doing the exact same thing we did on the last problem. I'm going to underline my x squareds. I've only got 2 of them. I have 2x squared minus 1x squared gives me x squared. Get rid of them. I have plus x plus 4x. Well, 1 plus 4 gives me 5x. Cross those out. And now it looks like I have negative 4 minus 1 gives me minus 5. And that is a squared. So I have nothing else I can combine. I'm finished. So that's the big thing there, guys. You got to watch out. Distribute your negatives if you have to. Let's go to the next page. Now 3 and 4 are basically just set up different. So these are just set up vertically, but look, they're set up vertically with the same symbols. Now, we are talking about like x squared, y squared, xy squared, but don't let those scare you. It's just a symbol. If I have x squared, y squared, I can only combine it with other x squareds, y squareds. So if I have 4x squared y squared plus 6x squared y squared, I get 10. return the thing on there, 10 x squared y squared. I'm done with both of those. The next two both have xy. Well, 5 plus 8 is 13, so 13 xy. I have xy squared, negative 3 plus 3 is 0. So there's my answer. So don't let those weird symbols bother you. Just match it up with the same symbol. Number 4 can be a little trickier because now we're subtracting, so we kind of need to distribute our 1 first. So instead of plus 5m, I have negative 5m. Instead of negative 6m, I have positive. Instead of positive 17, I have negative. And now I can just add them together. 11 minus 5 gives me 6m squared. 2m plus 6m gives me 8m. Negative 11 minus 17 gives me negative 28. So be careful on the subtraction ones. I want you to watch right there. You have to distribute the negative. Okay? If you have any questions on that, just feel free to come ask me in class. Now, number 5 is probably the easiest one we've done. It's a positive, or we're adding, so if I distribute, nothing changes. So let's just leave the parentheses. Let's start with our 3a squared. If I look at the rest of my terms, there are no other a squareds, so I just pull it down. 3a squared. Now I'm going to come over here to plus 3ab. Well, I do have a plus 4ab over here. 3 plus 4 is 7ab. Now I have negative b squared. I have a positive 6b squared, which gives me plus 5b squared. So that's all there is to that one. That will work on addition problems, but it will not work on the second one as far as like just leaving the parentheses. This one is subtraction. We have to distribute our negative 1 before we can do anything. So I have 5y squared plus 7y plus 8. I distribute the negative. I have negative 2y squared plus 4y minus 3. But now we're right back in the same boat we were. So I'm going to look at my y squareds first. Looks like I have another one over here. 5y squared minus 2y squared is 3y squared. I have plus 7y, but also have this plus 4y. 7 plus 4 is 11y. I've got plus 8 minus 3. 8 minus 3 is plus 5. So once you distribute the negative 1, guys, it's just adding and matching, so be careful. Now, we're going to go down to number 7. This is a geometry application, and the rest are as well. You got to pay attention, okay? These all work basically the same way. It says the measure of two sides of this triangle are given. P is the perimeter. Find the measure of the third side. Now, they gave me all these polynomials, but I think if we look at a regular triangle with regular numbers first, it'll be easier. So let's say I got a triangle. I know one side's 1, one side's 2, but they tell me the perimeter is 5. Well, to find what this side x is, I'd have to take my perimeter and I have to subtract from it one of the sides and the other side. Whoops. And that would give me that the other side is 2. So we basically do the same thing. We're going to take the perimeter and subtract the pieces. So I'm going to take 4x squared plus 5x plus 5. And I'm going to subtract in parentheses one of the sides, 2x squared plus 3x plus 6. And subtract the other side, x squared plus 3x minus 5. Now this is going to have 3 of each term, it looks like, but no big deal. Now there is a negative 1 in front of both these parentheses, so I do have to distribute before I can combine. So I have 4x squared plus 5x plus 5 minus 2x squared minus 3x minus 6. I just distributed my negative, changed the signs. Minus x squared minus 3x plus 5. Now, I want you to pause it for a second, combine your like terms. If you did it, I have 4x squared minus 2x minus x squared, 4x squared minus 2x squared minus x squared. That gives me 1x squared left. I have a plus 5x minus 3x minus 3x. 5 minus 3 is 2. 2 minus 3 is negative x, negative 1x. I've got 5 minus 6 plus 5. 5 minus 6 is negative 1 plus 5 is plus 4. Now that's probably one of the longest questions you'll do. Write it out. Write carefully. Pay attention to your details. Let's go to the next page. Almost done. Now number 8 is a common type of problem in geometry. It says find the area of the shaded region if 9x squared minus 6xy plus 3y squared is the area of the total region. So the whole or area of that rectangle is the 9x squared minus 6xy plus 3y. And they want us to take out the 3x squared plus y squared. That's the area of the unshaded region. So I'm going to take the whole and subtract the unshaded region. So I'm going to put total area, total area minus the missing piece, or the white area, I guess we could say. So our total area, 9x squared minus 6xy plus 3y squared. And then I'm going to subtract from it the perimeter of the, or the area of the white area, 3x squared plus y squared. I have a -1 I've got to distribute. You can notice these are all really familiar. 9x squared minus 6xy plus 3y squared. -1 times 3x squared minus 3x squared minus y squared. Now we're right back where we were. I'm going to look at my x squareds first. Looks like I have two of them. 9x squared minus 3x squared gives me 6x squared. I have minus 6xy, but I don't have any other xy's, so I just keep it minus 6xy. Then I have 3y squared minus y squared, which gives me plus 2y squared. And that's all we can do. So if it asks for the area of the shaded region, take the total area minus the piece that's not shaded. Let's go to number 9. It's probably the easiest one. Now it says find the total area of the figure below. And if we're talking about total area, that means we've got to add them all together. So you could write it all out, take the middle rectangle's equation or polynomial, add those 4y squareds to it. Or we can just look at it how it is. I'm going to underline 13x squared. Well, I have no other x squareds, so it's just 13x squared. I'm going to write out here to add them so I don't forget. Now I go to xy. Well, I only have one xy. There's no other one, so plus xy. But now I come over to y squared. Well, I've got 4 or 5 of those, so I have 1, 2, 3, 4, 5 y squared plus 5 y squared. So not too bad. That only works if it's addition. If they're talking about subtraction, you have to write it out so that you make sure and distribute your negatives. Now let's look at this last one real quick. It says find the area of the shaded region if the area of the total region is 5x squared minus 4xy plus 2. So this is a lot like number 8, except now I'm not just subtracting one thing, I'm subtracting 2. So I'm going to take my total area, 5x squared minus 4xy plus 2. I'm going to subtract the two pieces. I've got x squared is one of them. The other one is xy. I distribute my negatives. I get 5x squared minus 4xy plus 2 minus x squared minus xy. Now you may not need the parentheses right here so much, but you should get in practice so you don't mess it up. Now we just combine like terms. 5x squared minus x squared is 4x squared. I have negative 4xy minus xy, that's negative 5xy. And all I have left after that is 2. Now guys, this is not very bad. It's just matching and then adding or subtracting. If you're not sure about the smaller numbers, don't feel bad about using a calculator. Make sure you get it right. The other thing you might want to do is write neatly. If you have any other questions, just let me know in class. Good luck.